Assalamu alaikum. Activity-based costing. This is the topic of our discussion. We have seen that compared to the traditional costing system, the activity-based system uses various activities of the organization, and it uses cost drivers which will indicate how the costs are determined for that cost center, and by use of these cost drivers it is allocating overhead cost to products. It is important that you understand the working of the traditional costing system in order to be able to have a good understanding of the activity-based system. Under this system, we are going to find the activities, and you need to understand, therefore, what these cost drivers are. Both these things are important to be able to see the difference between the ABC and the traditional system. Activities, we have referred to examples that within the organization you are going to identify the various activities that are being performed, the various tasks that are being performed by the organization and its employees, and find the cost determinant. The cost driver, therefore, it's important to understand, the cost driver is that factor which determines what is going to be the cost of that activity. We referred to the example, the simple example of purchases. The activity of purchasing, the costs that are going to be involved are identification of suppliers, receiving of requisitions, sending out the orders. These are the various sub-activities of this activity under purchasing. The cost driver is going to be that factor which will determine the cost of this activity. And we have used the purchase order as the cost driver for purchasing. In other words, we are saying the more purchase orders there are, the more will be the cost of purchasing. Purchasing will have to cater for the number of orders it expects. And that's where the cost driver comes in. So cost driver is like the purchase order for purchasing. It's important that this should be clearly understood at the early stage. So now let us look at the various aspects of activity-based costing. ABC systems create separate cost centers for each major support activity and allocates costs to products using cost drivers that are significant determinants of the cost of the activity. This is what we have said, that we are going to use cost drivers which are significant determinants of the cost. This is how the cost of the activity is determined. The ABC system recognizes that where a batch of two products consume the same quantity of purchasing, for example, receiving and inspection activities, it allocates the same cost to both products. That's how we are able to say that activity-based costing is going to be more accurate, because it is going to see the number of purchase orders consumed by a product and then allocate the cost of purchasing to that product accordingly. This is the concept, therefore, that we are not looking at the volume of output. We are not looking at production and quantity of production. As we were in the case of traditional system, normally we were looking at the units of output. We were looking at, for example, total machine hours, total direct labor hours, to gauge the amount of overhead resources being consumed by the product. As we have seen, that in case of purchasing, there might be two products which are produced in different quantities, but they both require the same number of purchase orders. Hence, the cost of purchasing will be allocated to both of them in equal proportions as they use the same number of purchase orders. So we come away from this concept of volume related cost driver or basis. The volume related basis, which uses volume as the basis. The more the production, the more the overheads. This is a generalized basis being used traditionally. So we are now under ABC coming away from this concept of volume related overheads allocation, and we are looking at non-volume related bases. Purchase order, there might be one purchase order and it might have 10 items being ordered in one purchase order, or it might have 5,000 orders, 5,000 items being ordered in one purchase order. So we are just looking at one purchase order, looking at the number of purchase orders to ascertain the cost being allocated to the product. We have therefore, as I said, gone away from the concept of volume related allocations and more or less come towards non-volume based overheads. Let's look at the next slide. Volume based and non-volume based cost drivers. These cost drivers are appropriate for measuring consumption of expenses such as machine energy costs, depreciation related to machine usage, and indirect labor employed in production centers. Volume-based cost drivers are appropriate in the above circumstances as activities are performed each time a unit of product is produced. This is what needs to be understood, therefore, that the volume implies each time a unit of product is being produced. As it is being produced, costs are being incurred, and there are certain costs which are going to increase or decrease as the production increases or decreases. But that won't always be the case. So there are going to be some costs which are not going to relate directly to the volume of production. When we look at, for example, energy cost of machines, the energy cost of machine will vary or increase or decrease according to the usage of the machine. Therefore, when we are allocating energy cost, to use a volume-based basis such as machine hours is an appropriate basis. But as we have discussed, that might not always be the case. Assuming that each time a unit is produced, the costs are going to increase, this might not be the most accurate basis to use. And we talked about the cost of purchasing. There can be the cost of production runs. There could be the cost of setting up machines. When you set up machine, the machine has been set up for one run. Now, in this run, you can produce 10,000 units, you can produce 50,000 units. So the number of units will not determine the cost of setups. It is the number of setups which is going to determine how much cost is being spent on setups, and therefore allocating the cost to the product according to the number of setups. We'll see that later on in an example. Now consider two activities: setting up a machine and re-engineering products. Setup resources are consumed each time a machine is changed from one product to another. It costs the same to set up a machine for 10 or 5,000 units. So in these two activities, re-engineering of products or setting up a machine, we have said that setting up a machine involves cleaning perhaps of the machine, ensuring the machine is working okay, the maintenance. It might involve placing startup materials into it. It might require various liquids and various other lubrication, etc. This setting up of a machine is necessary to start a production run. This production run, therefore, can be for a varying number of units, and so the cost of this setup is not related to the volume or the output number of units. And similarly, re-engineering works. You imagine you have a factory operation where various production and products are being produced, and there is an engineering works department which works on re-engineering of various objects and jobs. The parts might be re-engineered, some products might be re-engineered. That will depend on the amount of errors or amount of false production, wrong production, and therefore the amount of engineering work will relate to defective items. It will relate to defective production or defective parts. This will be unrelated to the quantity of units, good units being produced. And therefore, the cost of re-engineering can be regarded as a non-volume based cost. And so the allocation to various products, it would be appropriate to use some non-volume based allocation basis. ABC systems rely on a greater number and variety of second stage cost drivers. They use both volume based and non-volume based cost drivers. Traditional systems use only volume based cost drivers. Volume based cost drivers assume that a product's consumption of overhead resources is directly related to units produced. Typical volume based cost drivers used by traditional systems are units of output, direct labor hours, and machine hours. So traditional systems are using volume based drivers or cost bases, whereas for ABC we have seen that ABC uses both volume based as well as non-volume based. This makes this ABC system more accurate, more attractive, and people regard that the cost of product coming out from the ABC system is likely to be more accurate and reflect the resources consumed in a better way. Traditional systems use only the volume-based allocation basis. For example, it uses number of outputs, number of units of output, it could use machine hours, it could use direct labor hours. All these are related to the production and output of the factory. And it ignores the fact that certain overheads are going to be consumed on a basis which is not related to output. So we saw the example of engineering works, and we saw the example of machine setup, and we also spoke of purchasing. All these are various non-volume related bases which are used in the activity-based system and not in the traditional system. The number of setups rather than units produce a more appropriate measure of consumption of setup activity. And this is what we have talked about earlier. Similarly, product re-engineering costs may depend upon the number of different engineering works and not the number of units produced. For both these activities, non-volume based cost drivers such as a number of setups and engineering orders are needed for accurate assignment of these costs. Using only volume-based cost drivers to assign non-volume related overhead costs can result in reporting of distorted product costs. The extent of distortion depends on what proportion of total overhead costs the non-volume based overheads represent and the level of product diversity. So this is what we have said, that if we are using only the volume related basis for allocation of costs and estimation of consumption of resources, this might result in reporting of distorted cost. And of course, distorted costs can imply distorted profits. This distortion, we said, is less where we are, in addition to volume based, we are also using the non-volume based basis. The extent, we have said, how much difference will it make? How much will the non-volume based and the volume based bases make to the cost? This extent will depend upon the proportion in the total overheads of the non-volume based type of cost and to the volume based type of cost. In our example, if the overheads consisted mainly of costs such as costs related to setup and engineering works and purchasing, here the distortion would be greater than if the costs of overhead comprise mainly of those type of costs which can be estimated using the volume basis. If non-volume related overhead costs are only a small proportion of the total overhead costs, the distortion of product cost will not be significant. In these circumstances, traditional systems are likely to be acceptable. The situation where the costs which can be determined by the volume related basis forms a larger part of the overall overhead. In these situations, the distortion, we said, is going to be less. And where the distortion chances are less, in these circumstances, the traditional system can also be acceptable, as it will not give rise to much difference in the cost being allocated to the product. Product diversity. Product diversity applies when products consume different overhead activities in dissimilar proportions. Differences in product size, product complexity, size of batches, and setup times cause product diversity. So this leads us to this concept of product diversity. And we are saying that product diversity applies when the products consume different overheads in different proportions. Now, different overheads are being consumed in different proportions. So therefore, using a same or volume related basis will not be appropriate. And this might be because of the size of the product, because of the complexity of putting it together, and other factors such as these. So product diversity is going to be an element that will indicate whether the traditional systems will provide an acceptable basis or whether the activity-based system would be preferred. Diversity is higher. That means chances are traditional system will create greater distortions in the cost being allocated. If all products consume overhead resources in similar proportions, product diversity will be low and products will consume non-volume related activities in the same proportion as volume related activities. Product cost distortions will not occur with traditional product costing systems. Equally, therefore, where product diversity is low, then the resources and overheads consumed by products will not be in unequal proportion. The different overheads are going to be consumed in similar kind of proportions, and so the distortion will be lower and traditional will provide a better result. Two conditions, therefore, will lead to product cost distortion in traditional costing systems. Non-volume related overheads are a large proportion of total overheads, and product diversity applies. So therefore, we can summarize that there are two conditions which would lead to a distortion of costs in the traditional system. One, the proportion of non-volume related overheads is higher in the total overheads, and two, that product diversity exists. These two conditions, if they are present, then chances are that traditional system will give greater distortions in cost and the ABC should be used. Let's look at an example. This example of Boric Company. The Boric Company has only one overhead cost center. It currently operates a traditional costing system using direct labor hours to allocate overhead to products. The company produces several products, two of which are the HV and the LV. So the company has a traditional costing system using direct labor hours to allocate the overhead to products, and there are two products which are going to be considered here, the HV and the LV. HV is made in high volumes, whereas LV is made in low volumes. HV is produced in large production batches and consumes 30% of direct labor hours. LV has irregular and low demand, is produced in small batches and consumes only 5% of direct labor hours. So now we will see that where a company has direct labor hours as a basis for allocating overhead costs, it is producing various products. We are going to examine two of the products, the HV and the LV. The HV is a high volume kind of a product, and the LV is a low volume. HV consumes 30% of direct labor hours. LV is produced in low volumes, and therefore it has greater number of production runs, and it consumes only 5% of direct labor hours. This is an example which highlights two products where volume related activity, if the volume related basis is used, then 30% of labor hours are consumed by HV and 5% are consumed by LV. Whereas the number of production runs, HV is bound to have lower because it is produced in higher volumes, and LV, because of its lower production batches, is going to have greater number of production runs. Detailed investigations indicate that the number of batches processed causes the demand for overhead resources. So now we have seen that the number of batches processed will cause the demand for the resources and therefore will determine the cost being consumed. We saw that HV had lower number of batches and LV is likely to have a larger number of batches because it is produced in small batches. And if the number of batches is going to determine the cost, then basing the cost on something like volume related basis is going to provide a distortion. So the traditional system is therefore replaced with an ABC system using the number of batches processed as the cost driver. So in this situation, if the traditional system were to be used, then we might be using direct labor hours as the basis of allocating the overheads. But now, seeing that the costs are determined by the number of batches, so number of batches is a non-volume related activity. Now, non-volume related activity means that ABC system would be preferred. HV product is high volume product. It has low number of batches. Chances are that lower amount of overheads are being consumed. And the LV product, which has a lower volume and therefore a high number of batches, will mean that it is going to consume a greater amount of the overhead. You ascertain that each product accounts for 15% of batches processed during the period, and overheads assigned to the cost center amount to 1 million. Now the overhead is 1 million, and the use of batches, it turns out, is 15% for both products. So equal amount of batches are being produced and 1 million is the overhead. Let's see how to allocate this cost. The direct costs and sales revenues assigned to products are as follows. HV and LV, direct costs 310,000, 40,000. Sales revenue, HV 600,000, LV 150,000. Show the product profitability analysis for product HV and LV using traditional and ABC systems. So now we have to compare and use both the systems and see in our example what would be the result of allocating the cost to the products. We found that HV has sales revenue of 600,000, LV has 150,000, whereas the direct cost of HV was 310,000 and LV was 40,000. The reported product costs and profits for the two products are as follows. Traditional system, ABC system. Both the products, let us look at the traditional system first, HV and LV. Direct costs, we are told 310 and 40. The overheads being allocated to HV will use direct labor hours as the basis of allocation under the traditional method. HV, remember, had 30% of direct labor hours, whereas LV had 5% of direct labor hours. So the overall overheads of 1 million, on the basis of direct labor hours of 30%, 300,000 of the overhead cost will be allocated to HV. And for LV, where 5% direct labor hours are used, out of 1 million, 50,000 of overhead costs will be allocated to this product. The reported profits and losses will show 10,000 loss for HV, 60,000 profit for LV, where revenues are 600,000 and 150,000. So here we can see that under the traditional method, we have used direct labor hours as a basis to allocate the overhead cost. Overhead cost, we said, was 1 million, and we have used direct labor hours as a basis to allocate the overheads. Now, HV was consuming 30% of direct labor hours. So therefore, on this basis, 30% of the overhead cost would be allocated to HV. That amounts to 300,000. And because LV is consuming 5% of the hours, 5% of the overhead will be allocated to it, which is 50,000. On this basis, LV will show a loss of 10,000 and HV will show a profit of 60,000 because of the amount of overhead allocated to each product. Let's look what happens under the ABC system, where direct costs remain the same, that is HV 310 and LV 40,000. Here we have said that the activity which reflects the consumption of resources is the number of batches. And we are told that 15% of the batches are consumed by HV and 15% also by LV. So here when you look at the overhead of 1 million and allocate 15% to HV, that amounts to 150,000, and also 15% to LV, that amounts to 150,000. Now the reported profit for HV will be 140,000 and LV is going to show a loss of 40,000. That's the kind of difference the allocation of overhead is going to make. In our example, the figures and the situation is such so as to very easily highlight the difference between the traditional system and the ABC. And so in this example, it has been, the data is such that there is a sharp difference and it reflects a great difference to make it clear. Making, for example, batches as the basis of allocation of overheads. So where the traditional system was showing for HV a 10,000 loss, the ABC system is showing a loss for LV of 40,000. Allocation of overheads will have a big impact on the cost allocated to each product and therefore on the profitability. Many decisions could be made on profitability of products, such as discontinuing, special orders, things like that. Where the consumption of overheads is estimated or inaccurate, the decisions can be wrong, inappropriate, because the costs are going to be distorted. So therefore, there is a need to very closely identify the overhead cost related to each product. And activity-based costing is examining the activities, and it is then using a basis, an appropriate basis for the allocation of overheads. Such is the difference that from showing a profit LV of 60,000 ends up showing a loss of 40,000. That's the kind of distortion and variation that overhead allocation can have. Allocation of 1 million overheads using direct labor hours as allocation base for traditional system and number of batches processed as cost driver for ABC. So by the use of this example, we have seen just how much the impact is of using an inappropriate basis for the allocation of overheads, and just how important it is to have a more accurate and a more appropriate basis to allocate the overheads to the cost of the product. Product costing will reflect its profitability, and management is faced regularly with decisions such as to continue the product or to discontinue. And of course, the whole object of providing this kind of information is to highlight which products are producing profits and which are producing losses, and therefore which might be considered for discontinuing and which product should be continued. These kind of decisions are going to be taken based on your analysis of product cost. In this example of Boric Company, HV is high volume product that consumes 30% of direct labor hours, whereas LV, the low volume product, consumes only 5%. The traditional system that uses direct labor hours as the allocation base allocated 6 times more overhead to product HV, 5% compared to 30%. Therefore, the traditional system will allocate 6 times more overhead. However, ABC recognizes that overheads are caused by other factors. In this example, they are caused by the number of batches processed, and ABC uses this as the cost driver. Both products require 15% of total number of batches, so they are allocated an equal number of overheads. It is apparent that the traditional system based on direct labor hours will overcost high volume products. 6 times more overheads were assigned to HV as the consumption ratio for HV is 0.3 and LV is 0.05. When number of batches processed is used as the cost driver, the consumption ratio is 0.1 for both, and an equal amount of overhead is assigned. Distorted product costs are reported with the traditional system that uses volume-based cost driver because 2 conditions specified above apply. 1. Non-volume overheads are a large proportion of total overheads, in our case 100%, and product diversity exists as consumption ratios for the 2 identified cost drivers are significantly different. So this example has been used to illustrate how using ABC system compared to the traditional system can provide a different and arguably a more accurate basis for allocation of costs. We are regarding costs as consumption of resources, and so the basis used as consumption of resources should be most appropriate. It will not always be volume related or output related or machine hours and labor hour related. Very often we will have to look at the non-volume related overhead and non-volume related basis to allocate this overhead. The next thing we will do is to see how an ABC system can be designed. Designing ABC systems. 4 steps are involved. Identifying major activities that take place in an organization, assigning costs to cost pools, cost centers for each activity, determining the cost driver for each major activity, assigning the cost of activities to products based on products' demand for activities. So in designing the ABC system, there are 4 steps that are involved. The first step is to identify the activities in the organization. Activities in the organization. What is the organization doing? what are the people in the organization doing, what are they involved in. So you divide the entire organization's work into various activities. The next stage is to allocate costs to these activities and accumulate these costs in cost pools. The third step is to take a suitable cost driver. The cost driver, we said, is a factor which is going to determine the cost in the activity. And the factor which is most likely going to lead to significant cost of the activity should be selected as the cost driver for that activity. And in the fourth step, we said we are going to use this cost driver and allocate the overhead cost to the cost object or the cost product. Identifying activities. Activities are composed of units of work or tasks. For example, purchase of materials. This activity consists of many different tasks such as receiving a purchase request, identifying suppliers, preparing purchase orders, mailing purchase orders, and performing follow-ups. Activities are identified by carrying out an activity analysis. Starting point is to examine the physical plan of the workplace and the payroll listing to ensure all relevant personnel have been taken into consideration. Activities need to be identified. And the way in which this is being suggested is to take a physical plan of the entire facility and also take the payroll list to make sure you have all the personnel involved included in your study, and to identify what tasks are being performed. And where tasks can be grouped together, that group of tasks will form the activity. This has to be supplemented by a series of interviews for having staff complete a timesheet for a specific period, explaining how their time is spent. Many detailed tasks are likely to be identified, but after further interviews, the main activities will emerge. This will be the process to be followed. After examining the tasks, you might need to interview the people involved to identify what activity is being carried out. And this might be a very complex and long-drawn exercise with little bits of tasks being covered. So in these situations, it would be appropriate to group the tasks and to continue to interview the people. And suddenly, you will find that a main activity will emerge from a group of activities. So one has to be careful of the number of activities that should be incorporated. The cost will have to be borne in mind of accumulating information relating to activities if it goes beyond a certain number. Number of purchase orders may give a good explanation of purchase costs, but inappropriate for costs relating to receiving and issuing. Hence, it is preferable to break it into 3 activities and establish separate cost drivers for each. The final choice of activities must be a matter of judgment, but it is likely to be influenced by factors such as total cost of activity center, must be significant to justify separate treatment, and the ability of a single cost driver to provide satisfactory determinant of cost activity. Where this is not possible, further decomposition of activity will be necessary. Thus, all activities that have the same cost driver can be merged to form a single activity. Step 2. Assigning costs to activity cost centers. In this stage, we are going to assign the cost to the cost center. After the activities have been identified, the cost of resources consumed over a period specified must be assigned to each activity. So we have to identify activities, and then we have to see the cost that has been incurred under each activity so that we can assign the cost to the activity. Many of the resources will be directly attributable to specific activity centers. For example, lighting and heating may be indirect and jointly shared by several activities. So here we are saying that some resources can be directly attributable to the specific activity center, but there will be others like lighting and heating, and these may be jointly shared by several activities. So in one hall where there is several activities going on, the lighting and heating will have to be shared among the activities. These should be assigned on the basis of cause and effect cost drivers to provide a reasonable estimate. In other words, in order to assign them, there should be the basis of cause and effect. How much has been used by which activity? How much resource has been used by which activity? Of course, this is an estimate, but in order to make the best estimate, we need to use the basis as real as possible to the cause of that cost. Arbitrary allocations should not be used. Here, this means we should not just make a certain percentage. Okay, lighting and heating, 3 activities, one will be 30%, the other will be 30%, the last will be 40%. This is an arbitrary allocation. We are trying to get as accurate a picture as possible of the allocation of our costs, and we want to use the accurate costs to arrive at the estimate of cost of each activity. So some kind of a basis which is as near accurate as possible. The greater the amount of costs apportioned to activity centers, the more arbitrary and less reliable will be the product cost information generated by the ABC system. That means if you are apportioning, and the apportioning is an arbitrary basis, so if most of your, or the greater the amount of cost that is apportioned among the activities, the less will be the reliability, and the less will be therefore the accuracy of the product cost. In order to arrive at the product cost, we are dividing the activities, and therefore we want the cost of each activity, and we want to know the resources consumed accurately by each activity. So here, in assigning the cost to activity centers, we should try to be as accurate as possible. Activities will need to be established, and there might be various different activities, but where a single cost driver can be used and can be identified with a number of different tasks, then that task will then form one single activity. Step 3. In order to assign activity center costs to a product, a cost driver must be selected for each activity. There are 3 types of activity cost drivers: transaction drivers, duration drivers, and intensity drivers. Transaction drivers such as number of purchase orders, number of customer orders, number of inspections, number of setups, all count the number of times an activity is performed. So the next stage is to identify the cost driver. Cost driver, we said, is a factor that is going to determine the cost of the activity. And there are 3 types, we are saying. One is the cost driver that can be called as a transaction driver. Transaction driver is basically examining the number of times that activity is performed. The next is duration driver. Duration-based driver is going to look at the time taken. It is going to see, for example, for setup activity, the number of hours. That is a duration driver that is going to see the number of hours that are going to be consumed by a particular product in setup activity. Intensity drivers involve direct charging based on actual activity resources committed to the product. For example, if activities require unskilled and skilled personnel, a duration driver would establish an average hourly rate to be assigned to the products, whereas an intensity driver would record the actual or estimated time for each type of personnel and assign the specific resources directly to the products. So intensity driver is going to look at the number of times this activity is going to be repeated, and so it would estimate for each type of different factors such as skilled labor or unskilled labor, and estimate the total cost that would occur within a period of time. Step 4 is assigning cost of activities to products. The final stage involves applying the cost driver rate to the product. The cost driver must be measurable in a way that enables it to be identified with the individual product. This is now the final step to allocate, using the cost driver, allocate the overhead to the product. It should be measurable. It should be easily identifiable. That's all for today. Thank you very much.